All right. Hello there. If you have made it this far, we're going to begin TLI preparations, which is actually a kind of easy thing to do, minus calculating the burn for yourself. One of the many amenities of NASP is that it's done for you. We're going to run the TLI concatenated checklist. It's a bit of a simplified version of the other three, and the reason is because, well, quite frankly, many of the systems are not implemented, and also tutorial for beginners. I'll tell you what we are going to do is just verify our docking probe is extended. This should not take more than literally half a second. I don't know why it's taking so long. The gaseous canister, so it goes and the thing just, it's fast. It's really fast. So we can run the TLI concatenated checklist here. We'll ensure translunar inject is set to inject. Emergency detection system, since we're using the booster again, we should turn that on. EMS delta. This one's quite easy. You're just going to run that for 10 seconds on delta V and norm. Once you've set that up, you're just going to check to make sure that, nothing greater than 0.1 has occurred. And then you're going to increase it to the test part, which is 158.6.8. And then delta V test. We'll run that down and see how it goes. Minus 1.2, that's looking good. So you can set it to standby, back to off, and then to delta V set. We'll touch that later. We'll need to ensure our GDC is aligned, which is kind of a little broken in Rancher right now. So if you just select 1, 2, CMC at set GDC like that, and you push the button, it will torque to where it needs to go. Oh, actually, hold up. Excuse me, set it to IMU, and then it shall torque to where it needs to go. There you go. The needles are, as far as I know, a little bit broken. However, aligning them is decently easy. You just punch in whatever roll, pitch, and yaw you're currently at. It does take, a considerable amount of time to get this thing to spin, though. And then you'll press hold GDC align. Or you could just do it this way. Now we'll verify our verb 48 has 31102. So the 3 signifies that we're attached to the S4B. The 1 signifies that we want plus X ullage out of both AC and BD. Or sorry, not AC and BD, out of, here we go, all 4 pitch jets, that is. So there's all 4 pitch and all 4 yaw jets. So there's the option to say use all of these jets, all the quads, for thrusting fore and aft, or you could use the 2 on the left and right, or the 2 on the top and bottom. And then the 0 and the 1 tell us, or this 0 tells us the deadband, and then the 2 tells us the rate. Under the second row, the 0 in the first position tells us that we want to use BD roll. A 1 in the first position will tell us we want to use AC roll. and then ones everywhere else. These are used to enable and disable the individual quads A, B, C, D. So if we had a quad failure on system B, for example, we like lost fuel on B, we could set this to 0, 1, 0, 1, 1. Or even better, since B we lost, we could switch to AC roll, so 1, 1, 0, 1, 1. And the spacecraft can still control itself relatively, not even relatively, actually remarkably well for an entire quad failure. So, verb 34, just so that we don't, need to do pro. Now we'll set our FTAI to Earth, and if we turn one of them on, it'll just torque to orbit rate display. Altitude and the slewing is already done for you. Especially the altitude. You can actually see it set itself at different points. In NASP, you'd have to do that on your own. Arm the pyros and set your DET to 2, 3, 4, 51. Like so. And now that we're up to the verb 37 enter, 15 enter, this is where we're going to start calculating our burn. And the reason we didn't do it before, even though the checklist has you, is because you're beginners. It might take you a while to find all those switches. And if you can't find them in time and you miss the burn, well, quite frankly, you break everything. So it's definitely a good idea, to make sure you've got all of that done before you calculate the burn if you're a beginner. Now we'll calculate. So this is kind of the hard part. We can clear all this for now. Let's go to the moon, since that's what we care about. Our angle of departure, as a rule of thumb, is always going to be 17. And then what we want to do is we want to increment this until our paraloon is 60 nautical miles altitude. Actually, this should be called parasynthian, not paraloon, but when we insert into orbit, it becomes the paraloon, so that's fine. We want it to be 60 nautical miles, but we also need to make sure that we pay attention to the return perigee, because we need to have it above a certain point so that we get the proper entry angle, but it needs to be below a certain point so that we get the proper so that we don't skip out of the atmosphere. We need the proper angle for the entry corridor. And you could see that our time to burn is 3 minutes and some odd seconds. We're going to close the burn planner real quick and just give ourselves a little bit of a time skip right on past, because we want to make sure we're giving ourselves ample time to do this burn. So now we've skipped like 5 minutes, and this burn would have been started after an entire hour into orbit. So, don't worry about missing something, or don't worry about, thinking you're taking too long for starting the calculation at 40 minutes. You're fine. Give yourself ample amount of time. You have plenty of time in Earth orbit. You're good. Now we can see we're a whole hour away. We're just going to increment this plus minus. That's what I usually do, and I could see I've actually decreased the paraloon, so actually I want to go minus plus, minus plus. We're at 53.9 minus plus. That's 69.4. So now we can spit in a 0 here and a 0 here, and then go plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, 60.1. And that's good. That's really it. If you wanted, you could slap in another 0 and get it perfect. like so. However, those changes would be so small at that point that it really doesn't matter. But here's your Hohmann transfer time. Again, these things are not calculated with Hohmann transfer, but that's just sort of the idealistic and simplified approach of reentry. You've got your sphere of influence angle degree, which sets the arrival angle when it enters the sphere of influence. So that basically changes the angle of, the parabola. And then our angle of departure, which we're just going to set to 17. That sets the departure angle. 17 is pretty good. So our estimated time of LOI is 61 hours, a little bit early in the mission, I'm not going to lie. And if we decrease it, it gets shorter, so. But this is a little bit early. That's fine. 60 nautical miles, our return perigee looks great. Let's execute. So we've got a whole ton of stuff given to us. And this is quite frankly, my least favorite part because I know what it all means. So I don't need to write down the pads, but I'll do it for you guys. TLI pad, so time base 6 program. Let's make this nice and big so that I can effectively do this. All right, so time base 6 program is 1 hour, 54 minutes, 28 seconds. The attitude for the ignition, which is not really that important since the S4B will be commanding the attitude for us, but it's 179,330 and 000. Our burn time is 5 minutes, 36 seconds. Our delta V compensated for cutoff is 10,440.6 feet per second. And this is going to be what we input into the EMS a little bit later. Our velocity after the burn will be 36,010 feet per second. The attitudes for separation. It says skip attitudes. So yeah, attitudes for separation is NA in reentry. And then for extraction is NA in reentry. And NASP, the S4B, is programmed to command a certain attitude, just as in real life. In reentry, the S4B just immediately enters attitude hold after the insertion is done. So a little bit different. Again, simplified. Our TLI 10-minute abort pitch is 000. So basically, we would just keep our roll and our yaw, but pitch to this and fire the SPS if we want to abort the TLI prior to 10 minutes later. So there we go. That's how you translate that pad. And we can input that delta V into the entry monitoring system. So that was 10,000. 440.6. 10,440.6. Very good. And that should be the only thing that warrants any sort of setup. Everything else will be available to us on the computer, so we can get back to running that checklist. And we key, see key V37 enter 15 enter. That just means verb 37 enter 15 enter. And now, since reentry models the J missions, program 15 is usable. However, in any mission prior to Apollo 15, program 47 was used to only monitor the burn. It didn't give you a countdown or anything like that. Program 15 was a later addition. Now in 33, we just want to make sure we've got that data right, so we can go ahead and open up that pad again. And since we're done typing on it, we can go ahead and make it smaller. Only did that so that it was easier and faster. You can see time base 6 begins at 154 hours, 28 minutes. Approximately 9.5 minutes later, that is about, 2 hours, 3 minutes, 58 seconds. So we're going to proceed on that. Delta V, 10,440.6, 10,440 is good enough. So we are go to proceed on that. Under now 95, we should get our time for ignition, our VG, so basically the velocity to go for cutoff, and our current velocity. And you can see we got a whole ton of time to skip. So now at this point, everything's set up. We can click this into Delta V. And go ahead and start skipping time. Now we don't want to do it too much, because as you can see, the S4B still needs to hold orbit rate, and as we're skipping, it will not. So we do need to make sure that we're being a little bit conservative on the time skipping. We can see our countdown has officially started. And I'm going to keep time skipping and basically balancing this to in attitude versus time skipping. And I'm going to go ahead and cut right back to when I'm close to the next part. So I'll bring us down to about 15 minutes, and then I'll come back. All right, we're back at around 13 minutes to the burn. So we're going to go ahead and keep on time skipping very lightly. We can see we're up to, times 10 speed. And we're going to bring it down to about 9 minutes, 30 seconds. There we go. We can see uplink activity, and we get the light for time base 6. Make sure we're counting up. And right when we hit the 9-minute mark, we're going to start the clock. Mark. And you could see it is not a coincidence that that light went out right when we started the clock. That is not a coincidence. That's how they timed starting the clock back before program 15 was ever a thing. So, yep, we did get that S2 SEP light on for 30 seconds. And everything looks set up with the ordeal. By the way, ordeal, this stands for orbit rate display, Earth and Lunar. It tells you your pitch angle down to local horizon. So we can see we are perfectly parallel with the horizon, more or less. The EMS, this is the entry monitoring system. It is a backup guidance system for the computer. It can assist in performing a manual reentry, and it will keep track of your delta V for burns. Once we are close to that ignition time, again, time skipping very lightly. At 1 minute and 45 seconds, we'll actually get a delta V, or we'll get a display blank on the keyboard. There we go, display blank. It's actually 1 minute and 30. There we go. 1 minute and 40, that is. Display is back up. We can turn on the TVC servo. Just number 1 is required. And that blank tells us that the delta V monitoring has been activated, which means that we should turn on the EMS as well so that the EMS can detect any delta V changes. At this point in time, the booster would be doing a whole ton of ullaging and things of that nature. Ullage is not simulated in reentry, so the booster can just, light. In real life, that fuel has been sloshing around in space after cutoff, so we need the little tiny thrusters on the pack here called the auxiliary propulsion unit, which is used to drive the attitude of the S4B. But it can apply some plus X thrusting, very small thrusting of about half a foot per second, and it'll bring that fuel right up into those fuel lines and for the ignition of the engine. We don't need to confirm this burn. We don't need to hit pro or anything, and that's just because this burn just monitors. It doesn't control anything. We can see fuel is leading and the ullage is now complete. That light is off. So we're ready for ignition. Don't need to confirm anything. The booster is entirely in control. Its instrument unit is controlling everything at this point. So there's ignition. And if you remember the pad, this burn took about 5 minutes and 35-ish seconds. So we'll go ahead and we can verify that our EMS is counting down. We're counting up from ignition. Row 2 delta V is counting down, and our row 3 total velocity is counting up. We'll just make sure that our pitch angle looks about right. Starting at a minus 15 pitch is decently normal, and that's just because, we're adjusting both our parasynthian and our perigee, our return back to Earth, as a free return trajectory. So eventually, at some point in the burn, very shortly most likely, this will begin terminal guidance steering, and it'll start pitching up and down on its own and doing that perfect insertion. You can, if you so desire, watch this entirely external. There is nothing to do here. The booster will cut itself off automatically. So you're more than welcome to sit back, watch, relax. You're supposed to key verb to freeze the display before shutdown and record the data. However, there's no reason you should keep the data for a future burn or something. The burn planners always know where you're currently positioned, so no need to math that out in reentry. So feel free, kick back, relax, watch the burn, or sit inside and, you know, watch the displays, hear the clicking, hear the engines, whatever suits your fancy. Your playstyle, I typically prefer, you know, a little bit of inside action. Maybe you wanna look out the window, watch the Earth as you're boosting on by. Whatever you want, up to you. So I'm gonna go ahead and go on mute, and I'll be back when this burn is complete. Alright, coming up on the end of that burn. Shut down. And yeah, don't worry that this keeps counting up. It's not supposed to in real life, but there is an oversight with the EMS. Right now, it's actually reading the gravity pulling us back. That's why it's adding to the delta V. In real life, there's actually a calibration for the accelerometer in there that reads that. And so it will only read acceleration above a certain threshold. So it's not a bug, it's an oversight. Now, that number resetting back to that on standby, that is a bug. That's just plain old a bug. Turn that off. See, key verb right at shutdown freezes the display. You could see the shutdown time. You can see the delta V to go, and you can see our current velocity is 35,763 feet per second. Key release would normally bring that display back to live. In reentry, it doesn't, because it's not flying the real program. So DVC servos off, safe our pyros, go back to inertial attitude, hit pro on the computer. And that's supposed to go back to program 0. If you didn't key verb, that would happen. However, simple verb 37 enter 00 enter will bring you back to program 0. And now at this point, this is supposed to be done after separation. However, there's no harm in doing it now, but you can close your high gain antenna circuit breakers. As long as you don't take the power switch to on, it's not going to bump into the slot panel. And that's it. Now at this point, you're just going to sit and drifting away from the Earth and wait for the transposition and docking. So I'll be back with you for that one. Thanks for watching.